Hey everybody, this is Larry. This is day 8 of the May Leetcode Daily Challenge. First day of the second week. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think. And it's Mother's Day weekend here in the US. So happy Mother's Day to your mothers out there. But anyway, today's problem is super palindrome. So let's go over it. So I usually solve these live, so it's a bit slow. Watch on 2x, fast forward, skip ahead, whatever you need to do. And okay, let's say you have a super palindrome. It's also the square of a palindrome. What does that mean? Square of a palindrome. Oh, okay. 76, but okay. So 4 number. Okay. That's interesting. So there are a couple of strategies to think about here. The number of them. So maybe you can pre-compute them, to be honest. It's a little bit tricky though, because for 10 to the 8th, it means, 10 to the 18th, it means it fits in the long, so you can't really do them in a naive way, because, they're 10 to the 9th number of numbers to square, right? Otherwise, if this was like a smaller, it was 10 to the 9, then you could easily just do 10 to the 4th or whatever it is, 10 to 4.5 or whatever it is. And then, pre-generate all of them and then do a binary search or just lookup search or whatever. But in this case, the first thing to note, of course, is that, you have some f of left. Another way to write this problem is, instead of looking between left and right, you can also do something like this, right? And this is from 0 to, so instead of, maybe another way of writing is from left to right is equal to f from 0 to right minus 0 to left minus 1, something like that. Usually, not usually, but it comes in handy a lot, and I'm trying to think whether this makes sense. Or at least it simplifies the question in that you don't have to do some weird math about starting. But maybe in this case, you might, maybe it's interesting. Let's see. On 4 digits, there are only 4 of them. I think maybe we can do some maths on it. So palindromes. How many palindromic numbers are there, right? Well, the number of palindromic numbers in there for this problem, actually, I guess, yeah. So basically, okay, I guess the math is kind of not tricky, but it takes another layer for me. So yeah, so for example, so you know that the max case is going to be 10 to the 18th, and you know that if you can do, that means that the regular palindromes have to be 10 to the 9 in that range, right? And here we can count how many palindromic sequences are there in 10 to the 9. Well, that's actually just 10 to the 9 over 2, say, right? Because for a palindrome, you only have to generate half of it, right? Because by definition, or half the digits, because by definition, for example, if you generate them intelligently instead of just doing it one by one, you can see that it's 1, 2, 3, 4, dot, 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 all the way to 9. And then instead of doing 10, you can see that the 2-digit ones have 11, 22, 33, dot, 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 99. Oops. And then, 10, and then you do 10, which is, if you reflect it to 3-digit, is 101, 202, 303, dot, dot, dot. And this is not technically in order, because, you could see 111, maybe technically I should have done it in order, actually. That's my bad. So that's 11, which is refracted, 12, 13, I think I just did it in a silly way. And all the way down to 999, right? And of course, you can see that, here for generation, you only care about half the digits. So this is roughly 10 to the 5th. And by that, you can generate every number, every palindrome, and then check whether, well, you could generate every palindrome, and then you could check whether the square of that is a palindrome. And that is relatively cheap, per se. So yeah, so let's get started on that then. I think the math is actually kind of interesting for, maybe, I don't know. Let's see. And there are a couple of cute ways to do it if you want to take advantage of certain things, but I'm just going to do for loop for I think, okay, I'm going to keep it dumb and silly for now. Yeah, I mean, maybe not. Maybe it's fine. Let's do a while loop and then we'll just break when it's ready. I'm trying to think. So what I'm thinking about is whether it's true that, let's say 130, let's say, you know, the right is equal to some number x, right? And we have some, we're going over some current times current, and where current is a palindrome, is, let's say we go, this number is greater than x. Then in this case, I was just trying to think about whether this is always going to be true, right? Because if this is always true, and I mean, okay, now that I pointed out, it seems maybe obvious, but I was just thinking in my head whether that is the case. So yeah. So okay, so let's start with current is equal to the little bit tricky part is depending how you want to do it. What I mean by that is that if you want to do it lazily, like I was going to do, and do the odd and even numbers at the same time, then you cannot terminate early, because you have to do the single digits. Like for example, if your maximum is going to be smaller, you have to do the digits. Maybe that's not true. Maybe I'll just do them in two separate loops. That makes sense. I was going to do them in the same time, but that's fine. Yeah. And do we have to count 0? No. Okay. The length is 1. Cannot have leading zeros. Does that count as a leading 0 with left is? It's not really a lead. Oh, okay. Oops. The next line would count me. There's no zeros, so that's fine. So then now let's do. Let's do the odds and then let's do the evens, I guess. Yeah, odd digits. Yeah. Oh wait, that's kind of awkward the way I'm doing it, I think. That's why I was worried about it. I guess I'll just terminate early if the only on the odd digits. Because then the even digits will have more digits, so then it always generates all the odd digits. So okay, maybe it's a little bit inefficient, but we'll figure out the correctness, and when you want to improve yourself afterwards, you can figure out how to upsolve it. But okay, so yeah, let's see. Let's also just convert left to int and right to int. Of course, in your language, it may be a little bit different because in Python, these have enough precision, right? Or bits or whatever. Okay, what do I want to do? Okay. I mean, I'm trying to think about whether doing string operation is too slow, but okay, let's do it this way, and then. And then we'll think about whether, if it's too slow, we'll do it. I'm just a little bit lazy, to be honest. There's nothing whatever about this, but yeah. So let's just have a set. Though I think this is unique, so you don't really need a set. Okay. If left current or count and also if p is greater than great, we break. Okay, and then now we do even. Oh, I lied about this. This is not odd digit. This is odd digit. And then now we're gonna do even digits. Though maybe I'm wrong on this one. I never know how to do it with negative index. Let's try that, though it's really inefficient. But for here, now we're gonna just copy and paste. I'm not gonna lie. Usually I type it out, but today I'm a little bit tired. That's my story and I'm sticking to it. But we don't break on this one. Okay, so then just return count to very end, and then let's give it a spin. 1 and 2 is the other ends that they give us. Ooh, that's not right? Oh, I'm dumb, of course, because I forgot to do the squaring part, as we talked about. Because this is a super palindrome, not just regular palindromes. This is probably right in regular palindrome. I don't know why I clicked on that back, but let's go super. I think there's a walrus operator. Oh, super is a keyword. Forgot. I'm just checking real quick whether this is this walrus operator. I haven't really gotten good at walrus operators yet because it's kind of new. So we'll see if this is. Oh, yeah, this would always never terminate. But at least it doesn't count. I mean, because if it doesn't work, it would complain about. Because this is infinite loop because I was just lazy. But if this didn't work, it would give me a syntax error. So that's all I wanted to check. So that's fine. And then now we do. This is an X. So yeah. So we're also going to do a lazy, I guess. Let's just do this. Yeah. Whoops. That's not. I mean, I wanted to do two things, but wait. Square. So we want only the square. Okay. How do I do this? Oh. Maybe that's probably good enough. And oh, this doesn't need a function anymore. So, well, I mean, it's probably good abstraction, but I am just a little bit whatever about it. And that's why you don't copy and paste, because the second you have to type it twice, and the second time you might just mess it up. And I have messed it up many times before, but for now this is short enough, and I'm a little bit lazy today. Int object. Oh right. That's awkward. I don't want to do another thing. Let's. Don't try this at home. This is bad Python, I think. But is this good Python? Or good enough Python? It's probably still bad. Ah, it's referenced before the whatever. Where's my code? I thought the walrus would save me. Oh, this is wrong though. This is X. And maybe that's what I was talking about. I didn't read the message. But okay, so that looks good. Let's of course try the obvious ones like big cases. 6, 9. Okay, so that's really wrong. Though I would also say 70 numbers is really small. How did I get this so wrong though? That's awkward. Did I miss something? Maybe even just start with something smaller. There's also this clearly. So what I would also say that if I might actually do something offline in theory, and then because now that you know that there's only 70 numbers, which maybe they shouldn't give it away, you can actually just print out a table and then submit that. But of course, maybe you wouldn't do it in an interview. But that's besides the point. Did I miss something? Why am I undercounting so much? So I am undercounting for a reason. So I think my concept should be right. Let's see. I just try the smaller one because this is gonna ruin me. Might still print out too much. This does what I wanted to do. What is 100 though? 100's a little awkward. Oh, I'm. This is wrong. That's why. What I don't want is the first. I skipped this ahead too much. I meant just remove the last digit. Oopsie daisies. Is that the right answer now? It's better answer. I don't know if this is the right answer. So that was just a little silly. Little fun debugging time. Okay, so that's good. And as I mentioned, if I mean, I'm going to submit this now. But if I had gotten a time limit exceeded or something like that, I would just, do this offline, generate an array of 70 elements, and then just do a binary search on it or something like that, at least for a contest. So yeah, so what is the complexity of this? As we talked about, I mean, we did it in the beginning of the thing because we don't want to implement something that's too slow, which is that for the domain of u is equal to 10 to the 18th, this runs in roughly 10 to how do I say it? 10 to the 18th, the 18 part over 4. So yeah, so that's basically how long this loop takes. I do things very inefficiently, to be honest, the way that I did it with converting it back to string and back and forth. But as I said, I focus on the problem, and there are definitely optimizations that you can do here as well. But I personally don't generally care about running time unless it's too long. I don't care about it if I have the roughly right complexity, and this one should be okay. Yeah, so this is basically our worst case for time, and for space, we actually don't even. Well, I mean, okay, maybe conceptually, if we do create the way that I did it, create a lot of strings, and references and stuff like that everywhere. But if you do it in a slightly not dumb way like I did, you could probably do it in all of one space by just reusing the correct memory in a lot of places. But yeah, that's all I have for this problem. It's kind of tricky. It's a little annoying, but I think the hard part about this problem is not necessarily the implementation. Even though I got that wrong too with I was just going too fast and I wasn't thinking about what I want these to be, and debugging time ended up costing me more anyway, so I need to slow down a little bit. But anyway, yeah, the implementation is not that tricky conceptually, and I had some copy and paste stuff here. There's some do not repeat yourself that you can clearly see. I'll leave that to you for you to do at home. This is not code that I'm super proud of per se, but yeah, but the hard part about this is saying 10 to the 18. Do not freak out and try to analyze what your algorithm could be, because I don't think I do any high machinery or any high power thing. I just kind of think, okay, we have a palindrome, let's just generate all the palindromes instead of whatever, right? Yeah, that's all I have for this problem. Let me know what you think. Hope y'all have a great weekend. Hit the like button, hit the subscribe button, join me on Discord, and happy Mother's Day to all y'all mothers out there. And yeah, to good mental health. Bye bye.